Today we're going to talk about solving quadratics with the quadratic formula. How the formula is derived from the Pythagorean theorem. If you want to take a look at this is just kind of how we get the formula from standard form, using that and then kind of going through. This should say how the formula is derived from standard form by using completing the square. So whenever we go through this, we'll use completing the square, and then it should actually rewrite into our formula. Our formula that we're going to use, and I'm going to ask you to memorize, is right here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. When trying to solve, a, b, and c might be best to be labeled first. You'll only receive them when you're in standard form. This can be used as a catch-all to solve any type of quadratic. So let's practice a little bit with using quadratic formula. As I said before, you can only use this whenever everything is in standard form. So let's set it all to 0. So negative 4x squared plus 3x minus 8 equals 0. And then since we're new to this, just off to the side here, I'm going to label a, b, and c. You can do this to start. Some of you will probably be like, okay, I get where a, b, and c come from. I don't need to, which is definitely fine. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm also going to rewrite it just so you can kind of see it using it for the first time. So x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times negative 8 all over 2 times 4. Simplify, x is equal to negative 3 plus or minus the square root of 9 plus 16 times 8. I do not have a calculator with me right now, so I'm going to do this freestyle. So 48 is 128 all over 8. X is equal to negative 3 plus or minus the square root of 137. I apologize, my pen still having trouble with. So 1 7 all over 8. And since 137, let me see here, 4, 7 is 11. I think that's a perfect square. So I'm going to say we are done, and that's going to be our solution. Like in the other videos that I made, please try the problem first. Now that you've got one down, try example 2, and then come back and go through the problem with me. All right, so hopefully you pause the video. Let's rewrite this. So negative 5x squared plus, minus 10x plus 3 equals 0. So x is equal to negative 10 plus or minus the square root of negative 10 squared minus 4 times negative 5 times 3 all over 2 times negative 5. So x is equal to 10 plus or minus the square root of 100 plus 20 times 3, so 60 all over negative 10. X is equal to 10 plus or minus the square root of 160 all over negative 10. So let's break this down. 160 is 16 and 10. 10 is going to create 5 and 2 Okay, but 16 is a perfect square, so this will become 4 root 10. So x is equal to 10 plus or minus 4 root 10 over 10. I'm sorry, negative 10. Now, a lot of you might be thinking, okay, there's a 10, and then there's a 10. So we can simplify and divide by 10, but you cannot simplify. Okay, I'm looking at the radical right now. Anything underneath the radical, as long as you broke it down, you can't do anything to simplify from underneath the radical itself. Everything that you simplify from has to come from the outside number, and all three have to have something in common. So in this case, I can divide each of these by 2. So I get x is equal to 5 plus or minus 2 root 10 over negative 5. You could also move that negative out front. It's totally up to you. You can also write this as negative 1 plus or minus 2 root 10 over negative 5. That's totally up to you. Just because at negative 5 you could split, so they're both negative at the bottom. I would suggest, though, just leaving it. Just leave it as 1. Makes your life so much easier. Okay. There you go. All right, go ahead and make sure to pause the video, try example number 3, and then that should be it for today. And after that, we'll start our new lesson. Hopefully you pause the video. Let's take a look at this one here. We've got 8x squared plus 16x minus 42 equals 0. Now, fun fact, I can actually take out, is it 2 from this? Right? So this would give me 4x squared plus 8x minus 21 equals 0. And then if I divide everything by 2, 0 divided by 2, that goes away. So now I'm looking at my a value of 4, my b value of 8, and my c value of negative 21. If you don't take out the 2 to start, that's fine. Just note at the very end, you're going to have to simplify, kind of like we did in example number 2. So x is equal to negative b, so negative 8, plus or minus the square root of b squared, so 8 squared, minus 4ac, so 4 times 4 times negative 21, all over 2a, so 2 times 4. X is equal to negative 8, plus or minus the square root of 64 plus 16 times 21, right? So 6 and then 1 and then 12 and 2 times 1 is carried 3, so 6, 33, or 336 all over 8. X is equal to negative 8 plus or minus the square root of, so I'm going to add 64 to this. And wow, look at that. Square root of 400. Perfect. So x is equal to negative 8 plus or minus 20 over 8. When doing this, you want to solve negative 8 plus 20 first and negative 8 minus 20 first before you divide. That's also another common misconception. A lot of people like to say, oh, 8 divided by 8, but do not do that. So this is going to give you negative 8 plus 20, which is 12 over 8, and then negative 8 minus 20, which is negative 28 over 8. So you're going to look at negative 4, and then if I divide each of these by 4, it should be 3 over 2. All right. Next up, in the next lesson, we'll talk about imaginary numbers. But make sure to check the syllabus, do the corresponding homework, and we'll see you next time.